Earth's orbiting junkyard threatens the space economy. Rocket and satellite litter is endangering private space commerce. Enter the cosmic debris tracking industry. You never see it in those lovely NASA pictures of Earth, but the space surrounding our pale blue dot is a cosmic junkyard. Debris abounds, moving at ludicrous speeds and presenting plenty of hassles for satellite operators who do business in orbit. This pollution poses an existential risk for greater commercialization of space from the grand ambitions of Elon Musk's SpaceX Corp and Jeff Bezos' Blue Origin LLC to other players who see promising futures for an array of space activities, from tourism to imaging to pharmaceutical research. In low Earth orbit, space debris travels at velocities approaching 5 miles per second, roughly 18,000 miles an hour, which gives even the tiniest bits of junk enormous destructive energy. A 1 centimeter wide aluminum sphere in low Earth orbit packs the kinetic equivalent of a safe moving at 60 miles an hour. If it hits your satellite, well, that could ruin the whole damn day. Aggregate too much debris in certain areas in low Earth orbit becomes increasingly difficult and far costlier environment for commercial companies. Today, satellite operators periodically maneuver the birds to avoid object strikes, just as NASA must do with the International Fake Station. The key, however, is knowing what's headed your way. A depiction of orbital debris in low Earth orbit. Knowing where the stuff is the first part of the problem, said Bill L., a research fellow at the Aerospace Corp, which specializes in tracking space debris. Over the longer term, we need to be getting much better tracking data, so satellite operators don't move unnecessarily. To that end, some entrepreneurs see profit potential in helping to catalog better all that junk up there. The detritus of decades of unmanned and manned spaceflight. From launch to operations to disposal, satellite operators need help monitoring orbital paths and the potential for objects to stray into a collision course. One such business is Leo Labs Incorporated of Menlo Park, California. Spun out of the research center SRI International last year, the company announced Monday it has raised $4 million from a group of investors, including Airbus Ventures from the San Jose, California-based venture capital fund established by Airbus Group SE 2 years ago. Leo Labs radar technology, to be used to keep an eye on all those pieces of high-speed trouble, evolved from research into the Earth's ionosphere at SRI. Also Monday, Leo Labs said it has opened a second radar tracking facility in Midland, Texas, joining one in central Alaska. Ultimately, the company aims to have a half dozen such sites there. Here, boy. Leo Labs says its 2 radar centers can track 95% of the 13,000 larger objects in low Earth orbit that the U.S. Defense Department monitors. The company plans to track almost 250,000 objects as its radar network expands. Commercial space in low Earth orbit is growing so rapidly, we really have to run quickly to keep up. Dan Seprely, Leo Labs' chief executive officer, said in an interview, "It's getting messier up there." The clutter in low Earth orbit has grown rapidly over the past decade. In January 2007, the Chinese government destroyed an aged weather satellite in a missile test, creating what was estimated to be 2,500 pieces of new debris. That was followed by the February 2009 collision of a defunct 1,900-pound Russian Cosmos satellite with a 1,200-pound Iridium Communications satellite 490 miles above Siberia, generating even more orbital waste. Both of those events greatly increased the amount of debris in the near-Earth space environment, thus pushing the threat posed by orbital debris even further towards what was described more than 15 years ago as on the verge of becoming significant, the National Research Council wrote in a 2011 report. Another potential threat lies with the European Space Agency's Invested Earth Observation Satellite, an 8-ton, 30-foot-long behemoth that ceased responding in April 2012. E-Vista-T orbits an altitude of 480 miles in a place where it could become a source of significant debris should it be struck. In its current state, the satellite will orbit for about 150 years before it degrades and falls into the atmosphere. Yet even though there's plenty of junk to track, the U.S. has been generous about sharing its data with its neighbors on the size of the stuff flying by and on where it is there. Historically, the U.S. Department of Defense has been the most authoritative tracker in deploying technology to monitor objects that could threaten satellites, both military and civilian NASA missions. The U.S. military now tracks some 200,000 million billion orbital satellites there, objects via radar, and maintains a public database that satellite operators and others can consult. The Air Force also alerts operators to potential collisions and has contracted with Lockheed Martin Incorporated to construct a $1 billion next-generation Spacefence radar system capable of tracking as many as 200,000 objects. The new fence will be able to track objects as small as a peanut M&M in low Earth orbit, a Lockheed Martin manager said in November when the Air Force and Army opened a new Air Force Space Fence Operations Center in Huntsville, Alabama. The project is expected to become operational next year. Seepley, of Leo Lab CEO, says this public largesse about data sharing won't dent business for commercial debris monitors. That's because many operators are eager for richer automated data, greater debris detail and resolution, plus longer lead times for trajectory predictions, which will allow for better traffic management. As part of its service package, Leo Labs can also customize data to a customer's specific needs. Low Earth orbit is likely to see even more business ventures in coming years. Earlier this month, the Indian Space Research Organization successfully launched 104 satellites for 7 nations aboard a single rocket, most of them small CubeSats, for a San Francisco-based imaging firm. These smaller satellites are far smaller and less expensive than traditional designs, with thousands likely to be deployed over time. Moreover, an array of companies, including Airbus and Richard Branson's Virgin Galactic, are also exploring new ways to launch many satellites, moving beyond the domain of large, costly rockets. Advancements in such work would likely lead to even more objects to track for low Earth orbit operators. Cascading collisions. Space junk expansion also raises questions about the status and pace of a collision cascading effect called the Kessler syndrome, in which flying junk collides and begets new junk, which collides with more junk, and then it gets all junky and stuff, eventually making low Earth orbit commercially dubious, I said. The effect is named after Donald Kessler, a retired NASA astrophysicist who described the scenario in a 1978 paper. Among debris researchers, a debate exists on whether it's even real. This has already begun. All right. This not mere situation was illustrated dramatically, albeit in an inaccurate Hollywood fashion, by Sandra Bullock and George Clooney in the 2013 film Gravity, which depicted the space shuttle's destruction by debris after Russia explodes a satellite. In a 2007 interview, even Kessler said that many people had exaggerated the worst-case outcomes of his predictions. We're not there yet. I don't want to raise this warning that the situation is spiraling out of control, because it's just not, Sieple said, calling the Kessler scenario kind of a boogeyman off the horizon. Ultimately, governments will likely need to regulate best practices more closely for players operating in low Earth orbit. There it is. With rules and more rules and even more rules mandating vehicle disposal and new funding for research into how to remove larger objects. Ayla and Kepri said, "It's kind of like the Wild West. There's this growing understanding that with more and more satellites going to space, debris could become a problem. There are also few techniques for safe disposal of a satellite at the end of its life, or one that goes kaput, or a space rocket. Researchers have begun modeling a variety of approaches, including giant mesh tethers and a 50-gram paper-thin spacecraft that would blanket space trash and propel it into the atmosphere so it can burn up. It's very easy to get something into orbit, and it's the dickens to get it out. Difficulty notwithstanding, the health of the commercial space business will be determined in part by the tidiness of that stretch of the final frontier reaching 1,200 miles into space. The more space junk there is, the more often satellites will need to be moved, and the better shielded they must be to withstand frequent plinks by space projectiles. Both of these boast operating expenses. It's kind of the human way. You look at the oceans or the environment or anything, and you think it's an infinite resource, and it isn't. So there's that.